Alright, it's a week later, and I ran into a saw that I can't fix without significant parts. That crankshaft is pretty much shot. There's a lot of play in the rod bearing, you know. I think that's what took out the case, because you can fit a 10,000 feeler gauge in between that bearing and the case. That's not going to work, you know. So, you know, this is the definition of hell for a shop, because you have to box everything up and, you know, put it over there and hope that you can remember how it all went back together. Got a lean running 390 that doesn't have a lot of time on it, but it's also run by a rather aggressive full-time logger. I'm going to start building my ultimate old man saw around this set of cases. And Bob sent me a set of, don't look at that number, that had me fooled for about 15 seconds. Sent me a set of gaskets for the 555. But here's a new set of cases, and what we're going to do is stuff a 562 crank in there, you know, ignition and EL48 carb, top end, muffler mod, just pretty much the whole stuff, you know, and make this a lighter saw for me, you know. Getting older and don't like vibrations and don't like heavy weight, and I'm going to put a lightweight Sujihara bar on it. And that'll be a project hopefully this weekend or next weekend, if you're interested. And then this saw right here, this one here I'd done a pop-up piston and a decked cylinder with a base gasket, and he wanted me to do the muffler mod that I do on my others. I protested because I like leaving that screen in there, but he wants my little tube, and he wants the insides gutted the way I do. So I'll get that done, and you know, customer's always right. I've got to build 3 or 4 sets of these, get them out the door. So that's what's going on this weekend. I've got to make a couple of outlet tubes for the 562 muffler mods I do. And what I find is it's best for me to take the plating off stock if I've got galvanized stock to work with. Just do it with a lathe instead of trying to grind it off. I don't want that one to fall into the endless pit of scrap. What I'll probably do is dimple it with a die grinder. See which one I have in here that'll do the job. And then I'll probably use a drill to make it, you know, close to being the diameter I want, make it a cleaner cut. Put that in the vise and drill that hole right there. And since I don't have the right size drill, I'm going to have to use a die grinder to open this up to make that kind of a slip fit. It can't be too loose, otherwise it just drops right in when you're trying to braze it, you know what I'm saying? You got to make it where it's you got to push it in. And that's the trick. You know, and you have to kind of look at this like you're painting a picture. You know, if you have the right size drill, that sure makes it easy, you know what I'm saying? But if you don't and have this situation, it's really easy to over grind and make it too big. And you got to make sure you have safety glasses, because this stuff is coming at you. You know what I'm saying? So that's pretty close. As soon as I feel it where I can start getting it to start depressing a little bit, that's when I stop with the grinding and start with the tapping and tap it right in. So it's sort of a bit of an interference fit. The second thing I got to do is, once I've done that, is I've got to take all the paint off so I can braze. Okay, I'm about where I want to be. Just like that. That sits right in there. Yeah, I can tap it in, tap it a little bit. But what I'm going to do now is get the paint off, and then we're going to braze it. See it begin to melt. You just let it go. Do its own thing. Just make sure that it got everything closed up and sealed up, and this one appears to have. But I'll take out that bump right there, you know. That's easy to do. So first thing I'll do is I'll hit it again with that abrasive wheel. It's like 50s in here, so I'll take the torch and warm that thing up just a little bit and then hit it with the high temperature paint. I usually put a rag over the saw when I'm doing this kind of stuff, so errant chips won't find their way into something so they can get done, you know, do any harm. And this one here is for a friend, not a professional. Now, one thing, this one here has got the pop-up piston, and it's got a trimmed cylinder, but it still has a base gasket. Also want to point out that it's got the old style 5-screw case, but I assembled this case with, the 3-bond 1184. And notice there's no leak there. Now, this is not a heavy use saw. This is an occasional user. Guy does a firewood. You know, it's probably got maybe 2 firewood seasons on it, maybe 1. I'm not sure how much. It doesn't have a whole lot of time. It's dirty, so I mean it's been used. But I think the point is that even with these cases here, you know, assembled using decent techniques, just simple mechanicking, you end up with a relatively solid saw. You know. Now, having said all that, one of the other issues you have with these 562s is when you drop that cylinder, the tolerance to the muffler is pretty tight, and the tolerance of these screws are pretty tight, and sometimes that muffler, when you tighten it down in there, will actually jack that cylinder. You have another one of these little clearance issues you get from a fairly high tolerance design like these. So many caveats to these things. That's why I just simply don't like doing videos on these of anything but just straight OEM repair, because there's so many ways you could trip yourself up on this saw and make an air leak. This is one of those saws you got to be careful of. Look at how those holes, that cylinder being down, that cylinder being down 30 thousandths. Look what it did to the holes. And really, the only way I'm going to solve this is not try to jam those screws in there. That's not the right approach. The right approach is for me to open those holes up just a little bit, and to make up that difference of the 30 thousandths lower, cylinder, which pushes all these holes out of line. Now here we go again. Seems like people like these, The damn shame for me is that these are going away. Husqvarna has chosen to keep the X-Torques around and let these go away with the introduction of the new 572. At least that's what I've heard. And I don't know, I've probably said it a couple of times. I happen to like these saws a lot. Nice new filter. Not a speck of dust on these. Just a really nice clean, brand new saw. Why would you? I'm sorry. Why would you do this to a saw? tell you why I'm going to do this. Is I'm going to get some good video of how these things go together, you know? And let that throttle cable come free. What I'm going to attempt to do on this one, and I may have done it in the prior ones, is leave all the intake intact, you know? And take the muffler off and do the modification to it. But I want to leave as much intact as I can so I minimize breaking and resealing of seals. And I've been getting some requests to do porting for people, and there's a few select people I'll do that for. But I don't want to have that as a business model for a whole lot of reasons. First of all, there's a lot of really good ones out there. Everybody's into it, you know. It's like one of those things that everybody and their brother is now a saw porter. I think I just want to stay with repair and possibly get into restorations. Now notice that these two wires, they go down to that grounding screw. Okay, get some good video of that. Make sure the video is even running. These two came out of that hole down there. Now I took the throttle cable with my fingers and released it from the cam. Pulled it out of there so it's free. We've got that fuel hose. We're not going to have to mess with the tank vent. That's not going to be a problem. I will have to break this connection right here because that line goes down to the ignition. What else? A couple little details. One is this cap that sits down here, which is held on by the handle. You have a pin that kind of bounces around in there that I pulled out of the handle. You have that square nut that sits behind the handle. You can see where it sat right there, and that threads through and bites it with that interesting red stuff. The problem with those versus actual nylon captured anti-vibration devices in nuts is it only takes a couple of times through a thread for that to go away. You might get 2 or 3 times before it loses its characteristics, whereas, you know, a lock nut maybe 10 times. So anyway, just get a good look at the saw, you know. Nice looking machine, isn't it? They've got a funny looking flywheel. Here's one right there. You know, a lot of cooling area. And the one thing about these 576s, the 575, these were much further apart. 576, they got close together, and that's really the fundamental difference in the two saws. But the cases, the thing was designed to match the darn cylinder, you know what I'm saying? You know, and that's one of my beefs with the X-Torx is it's obviously a cob job because that cylinder does not match up with the cases well at all. Where this was designed to be what it is. I'm still curious as to why that failed though. That longer screw goes into this. I want to note that that white plastic bracket sits right there. So I'm going to disconnect this, and I'm also going to disconnect that. You see how that yellow wire goes up to this one here? So you got the red one to red, the yellow one to this tab right there. Now these two go back to the ignition system. The next thing is the anti-vibes. I'm just going to detach them. I'm going to take the muffler off. But at this point in time, that whole side of the saw should be free. When I was a young manufacturing engineer, it's actually a funny story to me, maybe not to you. One of my jobs was programming CNC equipment, in particular a CNC lathe, and one of the shops was in Brooklyn, New York, that I did the work for. Top of the Gilwanis Canal company's long since gone then. I think they're completely out of business, actually. Wow, that's in there. And I had a lathe operator, and the guy's name is, and I kid you not, Tony Orlando, like the singer. And hell of a nice guy. Hell of a nice guy. But this poor fella just had bad luck, you know? No other way of putting it. He just had horrible luck. And I don't know if I should tell the story. I'll tell some of the story. I'm not going to tell the whole story. How's that? We were machining these threads onto a large cast pot that was used for holding electrical equipment in mines. So the idea was, you had this big giant cast iron pot that was probably a couple of gallons. And at the top there was a thread, and the length of the thread and the flatness in the flange was designed to mitigate damage if there was an explosion inside that box. Let's say there was gas as it got in the box, there was a spark, and it went poof. The flame from it would have to go all the way through those threads before it got out to the mine atmosphere. And the idea was that while it did that, it would lose temperature, so by the time it got to the, you know, the atmosphere outside the box, it was too cool to actually light off a much larger explosion. I don't know if that makes any sense, but there was entire product lines that were designed with that kind of concept. And of course, my job was to program the CNC lathes to thread those covers and then the flange of those big old pots. If you think about it, the first problem you're going to have, boy, they're short. The first problem you're going to have is how do you hold a pot that's like this long? And what we had was we had built these jaws, these chuck jaws, that would basically grab the pot around the end this way. It had a couple supporting pads here, but the majority of the clamping force was, if this was the pot, it was out around the end like that, right? Now imagine this pot's like this. So that's a lot of spinning material when those big jaws would grab a hold of that pot, and you run that thing up to a few hundred RPM to run a threading tool across. I mean, you had to get to a certain surface feet per minute to make the tool cut properly, right? So the part would be spinning and you're making a cut with a thread, making successive passes until you single point threaded that high tolerance thread, and you're holding the part around the end like this with these long jaws. And well, here's the problem: is there's only so much. It was an air chuck. There's almost only so much clamping force that air chuck had. So if you spun the RPMs too much, those jaws, just because of well, lack of a better word, centrifugal force, would begin to try to open up that chuck. The physics of that operation were pretty on the edge. It was a fairly edgy operation. So when we designed, well, when I designed the jaws, you had to hold them onto the air chuck with these T-nuts. And in order to get strong enough T-nuts, we actually had hardened T-nuts with hardened bolts. They were a little bit past grade 8 hard bolts. And that was what was used to hold those jaws. Had two bolts, middle and the top, those jaws onto the T-nuts in the slots in the air chuck, right? I don't know if anyone can visualize that. If you've done NC work, it's it probably makes total sense. If you haven't, it probably makes no sense. So anyway, what I would do is I'd make sure that there was a box that had all those parts in it. The jaws, the T-nuts, and the bolts. And the box was closed. When you did the job, you took that box, you used all those components, and when you're done, you put it back in that box. Well, a couple years go by. And I was out in the shop, because one of the jobs I had to do was set up Warner Swayze 2ACs. Those are like mechanical chucking machines. And, you know, one of them deals where all of a sudden you hear this, well, bam! And kind of a shh, kind of a whooshing sound. And all the guys in the shop are like, whoa! And you always know, if you've ever been in a shop and you get that kind of reaction, something really bad happened. And it was coming from the corner that had that CNC lathe, so I just had this sick feeling that I need to get over there really quickly. And of course I did. And there was this fella, Tony, standing by the machine, white as a sheet, froze. The machine's still going, and there was one jaw that was kind of like dangling, bonk, 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 hitting the bed, beating on the bed, and there was one of these on the shroud above the chuck, and sitting on top of that was one of the jaws. Another jaw was sitting down inside the machine. The pot went through the back of the machine, and one of these blew through the metal in the back, and it was still spinning on the wall, just going shh, shh, shh. By the time I got there, so of course I hit the red button. And I think you could probably guess the story. So now we had to figure out what in hell's name happened. So, you know, after we got him all calmed down, we had to go through and debug the job, you know, because it was a fairly expensive cover that just got fragged. And fortunately nobody got hurt. What happened? I don't know. I just turned it on. It was making like the second or third cut. I'd already done a couple of boxes and the thing just went BAM! So I'm like, alright. So we started taking apart the job. And to make a long story short, one thing led to another, and he needed those hardened T-nuts for another job, so he kind of used them, and they never went back into the box. And then a year or so goes by, he goes to set that job up. He didn't have any hardened T-nuts. He went and grabbed some out of the tool room, and they weren't hardened. And sure enough, the bolts just pulled the threads right out, and that's why it failed, because they were soft T-nuts instead of hardened T-nuts. Make sure that's out of the way. I'm not seeing anything connected. Off it comes. Alright. Make sure we have the things we need. After I get this one running, again, I want to go after that 390 and see what's going on with it. And then if I can get the 390 built where it's running good, I'm not sure what its problem is, it's running lean, then I think what I'm going to do is start the Ultimate Old Man Saw. Reason I brought up the old Tony Orlando story is that guy used to use these to torque his everything. He had a couple little pipes, and every one of his Allen wrenches he had a pipe that went right alongside it. It was really cool. So I kind of picked up that, and I buy a bunch of these, and they always lay around in my toolbox for situations just like this. Of course, with chainsaws, going into either aluminum or magnesium, you really don't need to have that kind of torque. Notice how I have that not going to hit here, and this one in particular, I made sure that it's not going past the face of the muffler, because it'll just get beat in. Now, one thing I got to do is I've got to check the squish on this one here. In my world, 20 thousandths is my goal. I don't want to go much below that. So I ran this one just a little bit, and I have an interesting toy here to show off. And so I check at two different levels. One is I check the squish now with the solder method, but I always like to look inside just to make sure that I haven't missed something. And if you look really closely, you see right in that area, just a little bit of a band. Now, that's not from impact, believe it or not. This kind of highlight stuff, it'll make you nervous if you overanalyze what you're seeing with this probe. So my guess is that squish is just a little bit tight. That high velocity of that gas kind of scrubs the top of that piston clean, and you sort of see that band. So what do we have here? I'll mash it down to somewhere around 20. Okay, I got it mashed down to 20. And if that just goes through with no resistance, then I'm happy, you know what I'm saying? Alright, so it didn't take much resistance. Let's take another couple of hits. Okay, I'm not feeling anything on that, so I may be wrong on my impression. Let me try that again. Just feeling it touch. What do we have for squish? Well, this is where it's interesting. The squish band itself is at 20, but right around the very, very edge, it looks like it mashes a little more. So let's see what that is. Because that drops down to about 15 thousandths. But that's what I'm getting. 15 thousandths on the very edge and 20 thousandths for the majority of it. That is so borderline.